Today we are going to discuss about on video lecture series about aero engine thermodynamics under the category of dual cycle. So previously we see that about the two application oriented of internal combustion engines regarding from Otto cycle and diesel cycle. But in this video, the dual cycle which elaborate with their applications and what are the process involved here and what are the mathematical equations here and what will be the efficiency and mean effective pressure which will be have obtained by the dual cycle. So in this PV diagram, it's a represent about this P, it is a pressure, it is a Newton per meter square, and the volume, it is a unit of meter cube. So this PV diagram which shows us about the here which indicates the 5 state of the process. So the process 1 to 2 is located, it is the basic and the initial stage, it is the adiabatic compression process. So the next category of state 2 to 3, it is the constant volume heat addition process, and the process of 3 to 4, it is a constant pressure heat addition process, and process 4 to 5 which indicate is the adiabatic expansion, and process 5 to 1 it is in a constant volume rejection part. So these 5 processes are involved and occupied in the dual cycle. So next we have to move through the what is this 5 process examine and what is this 5 process which will be incurred to attain the efficiency and mean effective pressure. Basically we know that efficiency it is equal to it is a work done by heat supply. So in this dual cycle, heat supply which represented two part, it is a state 2 to 3 and state 3 to 4. State 2 to 3 means Qs of 2 to 3 plus Qs of 3 to 4. These are the two processes which located as in a heat supply part. So here it is in the heat supply of process 2 to 3 which indicate is the constant volume addition. So the heat supply of constant volume is mCv T2 minus T1. Similarly for the Qs of 3 to 4 it is a constant pressure process. So it is indicated as mCp T4 minus T3. Here is a T3 minus T2. 2 it will be converted into 3 and 2 is converted into represented as 1. So this is the heat supply for the dual cycle. Next we have to find out the heat rejection of constant volume cycle. It is in heat rejection is a process 5 to 1. So this is mCv T5 minus T1. Next we have to substitute this heat supply and heat rejection in work done and heat supply. We get it the final efficiency equation. And the another condition that mean effective pressure MEP, which have been this the formula of work done by differentiation between V1 minus V2. So basically we have to find this V, it is straightly from the process, or we have equation of gas equation PV is equal to mRT. In this state we get it the equation of volume and another volume in expansion. So this dual cycle video is also have been incorporated in aircraft Aero engine thermodynamics. So this is the part of the aircraft section which combined of the all components of the aircraft. This dual cycle which will have been incorporated in during the operation of aircraft in cruise condition. Cruise condition means aircraft which is be in the running condition. So basically we know about the inlet section is a diffuser and compressor, and after that it is in a combustion chamber, and turbine and final part is in a nozzle. So this aircraft which have been incorporated in a dual cycle, which already we said that about the first process is a two adiabatic process and two constant volume process and one constant pressure process. These are the processes which have been incorporated in aircraft engine and which will be released the final output of the work done, the aircraft which will be forward to the forward condition. Thank you.